Hello everyone, my name is Viha and I'm studying in SVCE. My lesson is 1V22 IS 059. Today we're going to talk about Introduction to Lagrange's Theorem. Lagrange's theorem is a fundamental theorem in group theory that establishes a relationship between the order of finite groups and other orders of its subgroups. This theorem has significant applications in various areas of mathematics, including abstract algebra, number theory, and cryptography. So, what is the definition of Lagrange's theorem? It states that the order of any subgroup of a finite group must divide the order of the group itself. The order of a group refers to the number of elements it contains, while the order of a subgroup is the number of elements in the subgroup. This theorem provides a powerful tool for understanding the structure of finite groups. What are finite groups? Lagrange's theorem applies specifically to finite groups which have limited number of elements. A subgroup is a subset of a group that itself forms a group under the same operation. Order, the order of the group or a subgroup is the number of elements it contains. So now what are subgroups and cosets? A subgroup divides a group into smaller subsets called cosets. A left coset of a subgroup H in a group G is formed by multiplying all elements of H by a fixed element G in the subgroup G. The concept of cosets plays a crucial role in understanding Lagrange's theorem. So, what is a subset? A subset is a group that is itself a group under the same operation. What is a coset? Is partitions of a group into smaller subsets formed by multiplying elements of a subgroup by a fixed element. So Lagrange's theorem statement. Lagrange's theorem states that the order of any subgroup H of a finite group G divides the order of G. This means that the number of elements in H is a factor of the number of elements in G. The order of subgroup is given with the following notation, which divides the order of group G. This is the formula for Lagrange's theorem. Here's a proof for the Lagrange's theorem. This involves demonstrating that the left cosets of subgroup partition that a group into equal size sets. This is achieved by showing that any two left cosets are identical or disjoint and that every element of the group belongs to exactly one coset. Left coset form partitions of the group into smaller cosets. Disjoint cosets are two cosets that are disjoint if they share no common elements. Equal sized cosets or cosets of a subgroup have the same number of elements. Applications of Lagrange's theorem. These have numerous applications in group theory and other areas of mathematics. It is used to prove important results about the structure of finite groups such as Sylow theorems, which provide insights and existence of properties of subgroups of prime power order. Sylow theorem. These theorems state the existence of certain subgroups of prime power order in finite groups, finite fields. Lagrange's theorem is used to study the structure of of finite fields, which are essential in cryptography and coding theory. Number theory. It is applied in number theory to prove results about the order of elements in modular arithmetic. What are the limitations and expectations of Lagrange's theorem? Lagrange's theorem applies only to finite groups. It does not hold for infinite groups, as the order of a subgroup may not divide the order of the group in this case. The theorem also does not provide information about the existence of subgroups of a given order. The first one is the infinite groups. Lagrange's theorem does not apply to infinite groups. The next is the theorem does not guarantee the existence of subgroups of a specific order, which is again a question mark. Finally, for the conclusion and key takeaways, Lagrange's theorem is a fundamental result in group theory that establishes a connection between the order of finite group and the orders of its subgroups. The theorem has wide-ranging applications in mathematics and provides a powerful tools for understanding the structure of finite groups. First is finite group order. Lagrange's theorem applies to finite groups only, does not apply to infinite groups. Next is subgroup order. The order of subgroup divides the order of the group. This is the the theorem for the Lagrange's theorem. Next is cosets. Cosets play a crucial role in understanding the theorem's proof. Thank you and have a great day.